Society during his academic tenure. Like he's been the member of Indian Society of Technical Education. He also been the member of Indian Welding Society and Indian Institute of Production Engineers. He's also been the member of a renowned society, that is the American Society of Mechanical Engineers. He has more than 40 plus years of experience. Currently, he is working as a professor of mechanical engineering in Velammal Engineering College. Before that, he has worked as a professor in St. Joseph College of Engineering. He also worked there as an assistant professor and lecturer at the same college. During his working period, he has several key responsibilities in various organizations. Like we can say that he is the principal investigation for Naval Research Board project 2009-2011 for 12.66 lakh rupees, that is organized by the Ministry of Defence, DRDO. He has also organized a workshop on recent trends in friction welding and dissimilar metal, and also the machining of GRP composite funded by the same Naval Research Board, DRDO, Ministry of Defence. He is the management representative for implementing quality policy since January 2009 at his previous college, that is St. Joseph Engineering College. He has also been the responsible for obtaining recertification of the college to ISO standard at St. Joseph College. He is the head of Center for Training and Placement. He has organized national level conference MM 2003 in the year, TECM 2004 in the year, and TECM 2007. He is also the certified lead auditor for implementing ISO quality policy DNB Netherlands. He has also published many journals, some of them recent published are, which are under review, that is influence of different cooling method on drill temperature in drilling GFRP, that is in the International Journal of Advanced Manufacturing Technology. He has also published the same different publication, that is investigation on the influence of fluctuation in thrust force during drilling GFRP composite by reoccurrence quantification analysis in the same International Journal of Machine Tool and Manufacturing. In the year 2012, he has also published many renowned journals. He is the reviewer of many of the publication and the technical bodies, like in the International Journal of Advanced Manufacturing Technology, International Journal of the Production and Research Technology, International Journal of Machine Tools and Manufacturing Technology, and also the International Journal of Machining and Machinability of Materials. He has also been the key renewal for the 4th annual IEEE conference, which is held in Washington DC, USA, on the Automation Science and Engineering, that is case 2008. His area of interest are EDM, WEDM, conventional machining, friction welding, intelligent manufacturing system, FMS, CAD/CAM, optimized simulation annealing, genetic algorithm, and colony participation, particle storm optimization. He has been actively participated in preparing performa for NBA and UGC for several universities. He has also been as a question paper setter for Anna University, Chennai, and various other universities. Now I request the dignitary to take their seats in the and invite the chief guest to take over. Sir.
Mechanical Engineering Association and the faculty members for given such a wonderful support for me and invited me for this in giving this particular lecture. Since the audience is on the third years and final years, so I would like to brief about the friction welding, the recent advances in metal joining process and its applications. Actually, there are a lot of problems and in welding process. In fact, I myself started working welding as of now, and I have seen a lot of problems are there available because the major problem is joining of two metals. You have a lot of problems in this world. You have a lot of opportunities to work, and I can tell you that if you are really strong in welding, I think you can get a job. First thing I want to tell, because I have served as a placement officer for more than 5 years in the St. John's College of Engineering, so I know what's industry expectations as well. The most important thing is whatever you learn, you should go in a conceptual way. So there is something called rote learning, right? Just by heart something and reproduce that, and from there you can go for a meaningful learning. So rote learning is a wonderful skill. It must be there. You should have a rote learning, that is by hearting things. because there are certain formulas you need to by heart and you need to apply in an appropriate manner. Without by hearting certain things cannot be done. But question is, from rote learning, you can go up to meaningful learning. So there is a lot of difference. Wherever you stop, right now it's going to be meaningful learning. So if you achieve 100% meaningful learning, it means analysis and synthesis part. So that is the extreme end, where you can lead to patents or what you call, you become a scientist or whatever it is. Right? Now, as of now, what this industry requirement is, you should be able to get a job. Now, that is what you want. There are 3 options left. One is you can get a job, that's get placement. Second thing is go for higher studies, and again if you go for higher studies, again you need to get a job. At the end of the day, whether you get it now or later, that is a different thing. And the last one is become an entrepreneur. So these are 3 options left for you. So for these 3 options, there are a lot of skills required. So for which this particular topic will help you if you keep working on this one. Right? Now the first thing is I will concentrate on friction welding. So when I say friction welding, have you come across this one? Yes or no? Yes. Have you tried? No. Right. Now with this one I will let you know. So this is a rotary friction welding. To be frank, this one is a rotary friction welding. So you have 2 shafts, right? You have 2 shafts. I need to join these 2. And join these 2 in the sense, when you look for an arc welding process, right? Now you have 2 metals. What you do, you heat the metal to its melting point, apply some pressure, allow it to cool, you will get the solidification process. Now when you heat, when you apply pressure, that molten metal is not sufficient to make a stronger joint. So you go for a filler metal where it supplies excess molten metal. Now the electrode. Electrode, what happens? It melts. Electrode, in the consuming electrode, filler rod and electrode are one and same. So it supplies some excess molten metal. You pour some molten metal over the place that to be joined, right? You get a stronger joint. Now that is the purpose of the filler rod. You got it. Now that welding is different. This one is a solid state welding. The whole process in this one is a solid state welding. You don't go for melting point. The temperature is developed in such a way, it is not in liquid state. It is in a plastic state, like a clay, right? You can mold. You understand what I am saying? The metal will be in a plastic state. That is why you call this as a solid state welding. It is a solid state welding. Now, if you look into this one, you can see one is a rotary shaft. You can see this one is a rotary shaft, right? This one is a rotary shaft. This one is stationary. Now, what you do is you have a rotary shaft. You rub it against a stationary one. Create enough friction that will produce heat, that will melt the surfaces of the metal, right? Once it reaches a plastic state, you upset it, forge it. You got it what I said? You forge it. Once you forge it and hold it for some time during solidification, you get a stronger joint. Now this friction welding is a process which is invented recently. When I say which is invented recently, if you look into the literature, now you can see almost all aluminium are welded by friction welding. You understand? Almost all aluminium alloys and aluminium are welded by friction welding. The reason is aluminium is not weldable by other methods. If you go for a arc welding or any other welding technique, as soon as you weld, it will be followed by a hard-line crack. Aluminium is used mainly in aeronautical industries. So normally you go for aluminium because of less weight. For aeronautical applications, you need less weight metal. So normally they go for riveting. As far as aluminum is concerned, they go for riveting. Here they found